At 0100 hours on November 15th, 1942, USS Washington's radar operators watched a large contact appear on their SG surface search radar scope, range 8,400 yards, bearing 330 degrees. The target was a battleship. She was moving slowly through Iron Bottom Sound, unaware that American guns were tracking her through the darkness. 4 American destroyers were already sinking or burning. USS South Dakota, the other battleship in Task Force 64, had been battered by Japanese gunfire after electrical failures knocked out her systems. Japanese searchlights swept the water searching for more targets. But they couldn't find USS Washington. The Japanese battleship Kirishima had no radar. Her lookouts strained to see through pitch darkness. Her optical rangefinders were useless without light. Her fire control officers had no idea an American battleship was less than 5 miles away, guns trained on their ship, waiting for the order to fire. On Washington's bridge, Rear Admiral Willis Augustus Lee stood next to Captain Glenn Benson Davis. Lee had been tracking the Japanese force on radar for 20 minutes. He knew exactly where every enemy ship was. The Japanese knew nothing. Lee had spent years preparing for this moment. He understood radar better than any flag officer in the United States Navy. Now he would prove that electronics could defeat experience, training, and superior numbers. What happened in the next 7 minutes would change naval warfare forever. Night naval combat in 1942 was dominated by the Imperial Japanese Navy. For 2 decades, the Japanese had perfected tactics that made darkness their ally. Intensive training in low-light conditions, superior optical equipment, aggressive doctrine built around rapid torpedo attacks and close-range gunnery. Japanese destroyermen practiced night maneuvers until they could fight blind. Their commanders understood a fundamental truth. Darkness neutralized American advantages in firepower and industrial strength. This doctrine had produced devastating victories. In August 1942, at the Battle of Savo Island, Japanese cruisers surprised an Allied force and sank 4 heavy cruisers in 32 minutes. American ships had early radar systems, but commanders didn't trust the technology. By the time lookouts made visual identification, Japanese long-lance torpedoes were already in the water. The battle became a case study in what went wrong when radar was available but not properly used. USS Chicago had SC air search radar. The operator detected contacts at 43,000 yards, but the information took too long to reach the bridge. By the time the captain was informed, Japanese ships were already within visual range. The radar warning provided no advantage. USS Ralph Talbot, serving as a radar picket, detected Japanese ships but reported them as friendly. The formation commander didn't trust the radar data and didn't order his ships to battle stations. The Japanese achieved complete surprise, despite American radar detecting them miles away. In October, at Cape Esperance, American forces achieved surprise using radar but then lost control when the formation maneuvered into confusion. Rear Admiral Norman Scott had positioned his cruisers and destroyers in column formation. When radar detected Japanese ships, Scott maneuvered to cross their T, a classic tactical advantage. But in darkness, with ships maneuvering independently, the formation fell apart. Ships fired at contacts without knowing if they were friendly or enemy. USS Duncan engaged what she thought were Japanese ships. Some were friendly. Duncan was hit by American shells, then hit by Japanese shells, and sank. USS Boise was illuminated by Japanese searchlights and took multiple hits before American ships could support her. The Americans won tactically, sinking a Japanese heavy cruiser and destroyer, but the battle revealed how easily radar advantages could be lost through poor coordination. On November 13th, the first phase of the naval Battle of Guadalcanal became a point-blank brawl. American cruisers and destroyers engaged Japanese battleships at ranges under 3,000 yards. Ships fired at muzzle flashes. Searchlights blinded gun crews. USS Atlanta took 19 shell hits and a torpedo. USS Juno limped away damaged, only to be torpedoed and sunk by a Japanese submarine hours later. Rear Admiral Daniel Callahan and Rear Admiral Norman Scott both died in the action. They were the only two American admirals killed in surface combat during the entire Pacific War. The Americans had stopped the Japanese bombardment of Henderson Field, but at catastrophic cost. 4 destroyers sunk, 2 light cruisers sunk, multiple ships damaged, over 700 American sailors dead. The tactical victory came at a price that couldn't be sustained. The cruiser force was shattered. Most AT-AT. Surviving ships needed repairs. Henderson Field had been saved for one more night, but the Japanese were coming back. The Japanese lost battleship Hiei, crippled in the engagement and finished by aircraft on November 13th, and 2 destroyers. But they were preparing another attempt. Vice Admiral Nobutake Kondo was bringing battleship Kirishima south with cruisers and destroyers to shell Henderson Field on the night of November 14th. If the airfield was destroyed, Japanese reinforcements could land unopposed and retake Guadalcanal. The strategic situation was desperate. Guadalcanal represented the first American offensive of the Pacific War. If it failed, the entire strategy of island hopping toward Japan would be called into question. The Marines on Guadalcanal were exhausted. They'd been fighting for 3 months with inadequate supplies and constant Japanese attacks. Henderson Field was their lifeline. Aircraft from Henderson provided air cover for supply ships and attacked Japanese reinforcement convoys. Without Henderson, the Marines couldn't hold. Admiral William Halsey had almost nothing left to stop Kondo's bombardment force. The cruiser force was shattered. He had 1 operational aircraft carrier, USS Enterprise, but carrier aircraft couldn't fight at night. Halsey's only option was to strip Enterprise of her battleship escorts and send them into Iron Bottom Sound for another night engagement. It was a calculated risk. If the battleships were sunk, Enterprise would be vulnerable. But if Henderson Field was destroyed, Guadalcanal would be lost anyway. The problem was that night engagements favored the Japanese. American ships had better radar than they'd had at Savo Island or Cape Esperance, but radar alone hadn't prevented disasters. The technology had to be used correctly. It had to be integrated into tactics and command decisions. Most American flag officers in November 1942 still thought of radar as an interesting, experimental tool, not a weapon that could dominate combat. They'd been trained in an era when visual spotting and optical rangefinders were the only way to fight. Radar challenged decades of doctrine and experience. Most admirals were cautious about relying on it completely. Admiral Willis Lee was different. Lee understood radar because he'd studied it. He'd worked with engineers developing fire control systems. He'd examined British reports on radar-directed gunnery. He trained his crews to fight using radar as their primary sensor. When other admirals said radar was unproven, Lee said radar would decide who controlled the Pacific. Willis Augustus Lee was 54 years old in November 1942. Born in Kentucky in 1888, he graduated from the Naval Academy in 1908. His expertise wasn't in traditional naval skills. Lee was a marksman. At the 1920 Antwerp Olympics in Belgium, he won 7 medals in shooting competitions, 5 gold, 1 silver, 1 bronze. He was the most successful athlete at those games. His Olympic performance remained a record for 60 years until it was equaled in 1980. His specialty was long-range rifle shooting, where tiny variations in wind, temperature, and distance determined hits or misses. Lee understood that hitting targets at distance required precise measurement and calculation. Small errors accumulated over range. Wind drift had to be calculated. Temperature affected powder burn rates. Barometric pressure affected bullet trajectory. Lee became expert at measuring all these variables and incorporating them into his shooting. Lee understood precision. He saw battleship guns as instruments that required the same attention to variables that rifle shooting demanded. Range, speed, wind, ship motion, shell ballistics. Every factor had to be calculated correctly. For decades, navies had relied on optical rangefinders and visual spotting to provide that data. Lee recognized that radar could provide better data more accurately. Optical rangefinders measured range by comparing images from two lenses separated by several meters. The operator adjusted the images until they aligned, then read range from a scale. The process required good visibility, steady hands, and practice. Accuracy was typically 1% of range at best. At 10,000 yards, the error could be 100 yards or more. In darkness or poor visibility, optical rangefinders were nearly useless. Radar measured range by timing radio wave reflections. Radio waves traveled at the speed of light. The radar transmitted a pulse, measured how long until the echo returned, and calculated range from the time delay. The measurement was electronic, instantaneous, and unaffected by darkness, smoke, or weather. The Mark III fire control radar on Washington could measure range to within 40 yards plus 0.1% of range. At 10,000 yards, the error was less than 54 yards. This was twice as accurate as optical rangefinders in daylight, and infinitely better than optical rangefinders at night. Between the wars, Lee served as Director of Fleet Training at the Office of the Chief of Naval Operations. He worked on gunnery development and fire control systems. When radar technology emerged in the late 1930s, Lee immediately understood its implications. Radar could measure range more accurately than optical rangefinders. Radar could track targets in darkness, fog, or smoke. Radar could see over the horizon. If properly integrated with fire control computers, radar could revolutionize naval gunnery. Lee pushed for radar development and integration into fleet operations. He studied British reports on radar use in the Atlantic. He attended technical briefings on radar equipment. He visited research facilities developing radar systems. By the time radar-equipped ships began deploying to the fleet in 1941 and 42, Lee probably understood radar capabilities better than anyone at flag rank. Lee was given command of Battleship Division 6 in August 1942. The division consisted of two new North Carolina-class battleships, USS Washington and USS South Dakota. Both ships carried 9 16-inch guns in 3 triple turrets. Both had advanced radar systems. Both were fast, capable of 28 knots. Lee made Washington his flagship and immediately began training his crews in radar-directed gunnery. Lee's approach was radical. Traditional doctrine said radar was a backup to visual systems. Use radar to find targets, then switch to optical control for firing. Lee made radar the primary sensor. He reorganized Washington's fire control procedures, so radar operators worked directly with the gun directors and plotting rooms. Information flowed from radar to fire control without going through layers of bridge officers who might question or delay the data. Lee drilled his crews constantly. Track targets on radar. Calculate firing solutions from radar data. Fire without visual confirmation. Trust the electronics. USS Washington fired her main battery at night twice, in January 1942 during training exercises in Casco Bay, Maine. Both times the gunnery was directed entirely by radar. No visual sighting of the targets, no optical range finding, just radar providing data to the fire control computer. The results convinced Lee that radar could control accurate fire at ranges where visual spotting was impossible. Washington's shells landed close enough to the target sleds that Lee knew the system worked. But convincing the Navy required proving it in combat against a shooting enemy. Training exercises were one thing. Combat with ships maneuvering and shooting back was entirely different. The test came on November 14, 1942. Intelligence reports indicated Vice Admiral Nobutake Kondo was bringing a bombardment force to Guadalcanal. The force included battleship Kirishima, heavy cruisers Atago and Takao, light cruisers Sendai and Nagara, and 9 destroyers. Their mission was to destroy Henderson Field and land reinforcements. The Japanese had tried this twice in the previous 2 nights and been turned back both times. Now they were coming with overwhelming force. Halsey ordered Lee to take Task Force 64 and stop them. Lee had USS Washington, USS South Dakota, and 4 destroyers, USS Walkie, USS Benham, USS Preston, and USS Gwin. It was everything available. Most other American warships in the area were damaged or low on fuel or ammunition. Lee knew the odds. 6 ships against 1 battleship, 4 cruisers, and 9 destroyers. The Japanese had overwhelming numerical superiority. They had more guns, they had more torpedoes, they had better night fighting experience. They had the tactical initiative because they knew where they were going and when they needed to arrive. Lee would have to intercept them in waters. The Japanese knew intimately. Lee's only advantage was radar. He intended to use it completely. His plan was simple: position his force to intercept the Japanese as they approached Guadalcanal. Use the destroyers as a screen to deal with Japanese destroyers and absorb the initial torpedo attacks. Keep the battleships back in darkness where Japanese visual spotting couldn't find them. Use radar to track Japanese capital ships. Wait until the range was right, then open fire with radar-directed salvos. The plan required perfect radar performance, perfect fire control calculations, and enough luck to avoid being hit by torpedoes or found by Japanese searchlights. Lee accepted these risks because any other approach meant fighting on Japanese terms, and fighting on Japanese terms meant losing. Task Force 64 approached Guadalcanal from the south on the afternoon of November 14th. Japanese reconnaissance aircraft spotted the formation and reported the sighting. The Japanese identified the force as 1 battleship, 1 cruiser, and 4 destroyers. The identification was wrong, but close enough to alert Kondo that American ships were in the area. Both sides knew a battle was coming. The question was who would gain advantage when the fighting started. At 2300 hours, Lee's force rounded the western tip of Guadalcanal and headed north into Iron Bottom Sound. The passage between Guadalcanal and Savo Island was about 8 miles wide. It was a confined space for battleship operations. Maneuvering room was limited. The water was filled with wrecks from previous battles. Survivors from earlier engagements were still in the water on rafts. The tactical situation was as bad as it could be for capital ships. But Lee had no choice. If he stayed outside the Sound, the Japanese would bombard Henderson Field unopposed. He had to engage them here. The night was dark. No moon. Low clouds blocked starlight. Visibility was less than 1 mile. The sea was Fimes, calm with a light chop. The air was hot and humid. Temperature was about 85 degrees. The smell of jungle vegetation drifted across the water from Guadalcanal. Occasional lightning flashed in distant thunderstorms. It was perfect weather for radar and terrible weather for visual spotting. Washington's SG radar began picking up contacts beyond Savo Island at 23:05 hours. Multiple groups of ships moving south. Lee watched the radar plot display. He counted contacts. More than a dozen vessels in 3 groups. The Japanese bombardment force was approaching on schedule. Lee positioned his destroyers in line ahead of the 2 battleships, Walker, Benham, Preston, Gwin. The destroyers would screen against torpedo attacks and engage enemy destroyers. The battleships would hang back and use their radar advantage to engage the larger enemy units from distance. Lee sent a message over the TBS radio to all ships. "This is Lee. We're going into a big fight. Keep your heads. Stay alert. Trust your instruments." The technology that gave Washington her advantage had a remarkable history. Radar development in the United States began in the 1930s, but early systems were primitive. The breakthrough came from Britain. In September 1940, a British technical mission arrived in the United States carrying a black box containing the cavity magnetron. This device could generate microwave frequency radio waves at power levels useful for radar. British scientists had invented it at Birmingham University. They shared the technology with America in exchange for American industrial capacity to mass-produce radar systems. The Radiation Laboratory at the Massachusetts Institute of Technology received the magnetron in November 1940. Within months, engineers developed the first microwave radar prototypes. The SG surface search radar emerged from this work. It operated at